So we finished 3.1, which is all about combining like terms and simplifying some expressions. We now get to put that together with equations and solve equations that aren't just one-steppers. You see, before we just been doing one step at a time, one-step equations. Now we can make them a little more complicated, which is good because it gives you a very good foundation for the next couple classes you're going to take. So if you are keeping track right now, we're going to start section 3.2. And we're going to solve some basic equations. Hey, by the way, what makes an equation and an expression an expression? One of them has something, the other one doesn't. Good. Which one has the equal sign?
Equation.
Which one has no equal sign?
An expression.
Which one can you solve?
An equation.
Which one can you evaluate?
Expression.
Expressions. That's right. So we can solve equations. The stuff we did before, like yesterday, we couldn't solve that stuff. All we could do was combine like terms. We got down to the end of it, it was like negative 4m plus 7. You can't do anything with that. It's just there. But as soon as we have that equal sign, as soon as we do the equation, then we can start solving it. So just a little note for you. Equations have the equal sign, expressions don't. Equations equal, expressions no equal. These ones we can solve. These ones you can't solve. Also, one more thing. This is kind of awesome about equations. We found out equations are pretty much like a balancing act. As long as you do the same thing to both sides of your equation like a teeter-totter, it's going to be remaining level. And that's the idea here. We can add, we can subtract, we can multiply, and we can divide as long as we do it to both sides of our equation. Write that down, and then we'll get started on some equations here. We can add, we can subtract, we can multiply, we can divide, as long as you do it to both sides of your equation.
And that goes to expressions or what?
No, I'm sorry, this was a separate note. This is one thing, and this is another note. We can add, subtract, multiply, or divide as long as we do it to both sides of an equation. So expressions have no sides. Expressions don't have a side, they don't have an equal sign. The equal sign is what delineates two sides. So if we have an equal sign, we have sides. If we don't, well, then we don't. What I'm going to do now, we're going to kind of go through just a little review of some equations just to make sure we have these processes down. And then again, I'm going to start expanding on this so we can kind of get the hang of it first and then build. Ooh, let's all remember how to do this one. Firstly, equation, expression, what tells you what? That's definitely an equation. Why is that an equation? Good. And what the equal sign tells you is you have two sides here. The sides are like this. Right under the equal sign, you draw that vertical line that says I got two sides to it. Notice how you can't do that with an expression. There's no equal sign, therefore there's no sides. You wouldn't be able to do any of this stuff. So since we have x plus 8 equals 12, our variable is, what was our variable?
X.
We're trying to get x by itself. How do you get x by itself in this case?
Minus 8.
Good. We know we can do add, subtract, multiply, or divide as long as we do both sides. We subtract 8 here. Do we add 8 or subtract 8?
Subtract.
Got to look identical. This level has to look the same. You're taking away 8, you're taking away 8. On the left-hand side, what do we get? Sure, because the plus 8 and the minus 8, that's gone. On the right-hand side, what do we get?
4.
Notice how we're using addition rules, right? Because we're adding and subtracting different signs, subtract, sign of the bigger number. This is all old school stuff now. This is from like week 2 or 3. This is bringing all this stuff together for us, though. Could you check your answer?
Yeah.
Sure.
Yes. Add.
Plug it in. 4 plus 8 is 12. You know you get that right. We are going to go kind of quickly through these to make sure we're getting them, but we're moving fast. Okay, everybody, this one, our variable is what?
M.
What are we going to get rid of?
9.
How?
Line.
Good. We're doing the opposite of whatever's listed, so if we add 9 to both sides, we've got to be to both sides. We get m equals how much?
11.
Cool. So this is just a review for us, but we should know how to do these things. Z plus 12 equals 8. You tell me what to do. Quickly though. Minus what?
12.
Good. We're trying to get rid of the plus 12, so we subtract that from both sides. On the left-hand side, ladies and gentlemen, what do we have?
Z.
On the right-hand side. Why is it negative 4?
You subtract the higher number, keep the same sign.
Good. We're using addition rule. Different signs. Subtract. Sign of the bigger number gives us negative 4. And in fact, if you plug that in, negative 4 plus 12, that does give you 8. Will addition or subtraction work for this problem?
No.
What is going to work for this problem?
Multiplication.
So we learned,
Divide.
whoa, hang on, multiplication.
Division.
Okay. We already have multiplication. We're trying to undo the multiplication. So if we divide, yes, that's what's going to undo our multiplication for us. So if we divide both sides by what number? 28 or 4?
4.
X equals
7.
Perfect. Negative 2y equals negative 16. Am I supposed to add or subtract or multiply or divide here? Okay, we're dividing again. What are we dividing by?
Plus
2.
2.
Negative 2.
Oh, which one?
Plus 2.
Oh, yeah.
When we're dividing, you have to divide by the exact number that's in front of your variable. The reason is this. I want you watching the board right now if you're kind of iffy on this. If you're dividing by positive 2, what's negative 2 divided by positive 2?
Negative 1.
We don't want a negative, do we?
No.
What's a negative divided by a negative?
Positive.
That's going to give us what we want. And that's why you pick exactly the same thing all the time. So y equals how much?
8.
Positive 8 or negative?
Positive.
Very good. Negative and a negative is a positive. We'll draw our line under our equal sign for our equation. What are we going to do on this problem, ladies and gentlemen?
Divide.
Divide by what?
Negative 12.
Good, you're really getting the hang of this. This is awesome. Goes with the sign. You have to have that for division. It's got to be the same number. On the left-hand side, what are we getting?
B.
Negative 4.
Your other left. Yeah, negative 4 and B. Those negative 12s, those are gone because we know when we divide a number by itself, including negative, it creates a positive 1 for us. And last one we'll talk about before we move on. A over negative 4 equals negative 5. Oh my gosh, what do we do there? Why do we have to multiply?
Because you get the
A.
Good. That is. So we're going to multiply, what are we going to multiply by?
negative 5.
Negative 4.
Which one?
Negative
Which
4.
one are we trying to get rid of?
Negative 4.
Then that's the one you're going to want to multiply by. I'm putting it in parentheses on the right-hand side because I want to make sure you know that we're not subtracting, we are multiplying by the negative. Are you with me on this? On the left-hand side, those A's, those negative 4s are gone. We get A. On the right-hand side, what are we going to get?
20.
That's our answer. Would you raise your hand if you feel okay on all these problems that we just did? Good. That's a review of our Chapter 2 stuff. Now, what we're going to do in the rest of our Chapter 3.1 stuff is we're going to start adding on to these problems. So, for instance, if I'm looking at all this, these are all one-step problems. That's it. We just did one step, subtraction or addition or multiplication or division. But when we get down to a problem like this one, there's just a little bit more to it. We can't solve this problem in just one step. We've got a couple things we need to do. The first thing we need to do, and here's what we notice. I want you to look whenever you get an equation, if you have any like terms on each side of your equation. So for instance, here's my sides. Now, do I have any like terms?
Yeah.
Yes, negative 2 and negative 2.
Let me go back just one step to make something real clear to you. You kind of need to know this, so I'll do this. Are there any like terms here? Now, yeah, before you answer, before you're thinking, well, wait a second, aren't 8 and 12 like terms automatically?
No.
Here's how like terms are defined. Like terms have to be on the same side of an equation. Okay, that's how like terms are. So when you're talking about like terms, you're saying, are these like terms? There's only one term over here, so there's no like terms here. These are not like terms because they're on different sides of an equation. Nod your head if you're okay with that. Okay. So in our case, what I'm asking you is, do we have any like terms here?
Yes.
What are they?
Negative 2, negative 7.
Is this a like term with these ones?
No.
So I'm going to leave that 7 minus x minus 7 alone. And we're going to combine these two. Hey, notice how we're just doing combine like terms like we were before? We're circling those numbers with the signs. We're combining with addition rule like we know how to do already. This side stays the same. Negative 2 minus 6. How much is negative 2 minus 6?
Negative 8.
Sure. Just combine like terms. Well, now, does this look like something we've already had?
Yeah.
Now we can solve it.
So-
See, the idea is if you don't have like terms, you can't go about doing this stuff. It's not going to work for you. You're not going to be able to do it. Because if you tried to add 7 to both sides here, you'd be like, well, where's the 7 go? It doesn't really make sense. As soon as we combine like terms, now it makes sense that we can add 7 to both sides. So our idea is combine like terms first, then you're going to have something like we've seen before. Then you go about and solve it. How many people are with me on this? How do you solve this one again?
Negative 7.
X by itself, how specifically?
Add it.
Add 7.
Both sides, okay, good. On the left, I get X. On the right, I get
Negative 1.
Perfect, fantastic job. So combine like terms first, and then we have a problem we can work with. Let's do one more together. I'll give you just 2 to try on your own, and we'll start just moving on. You know, maybe we'll do 3 together. I'll give you 3 on your own. That'll work better. All right, guys, you got to tell me what's the first thing you're supposed to do on this problem.
Combine like terms.
That's exactly right. Do I have any like terms?
Yes.
Yes.
What are they?
2 y.
Good. So like terms are side by side. So we look at the left-hand side for like terms, and then we look at the right-hand side for like terms. On the right-hand side, it's just the 12, so we don't have any like terms there, but we certainly have some like terms on the left. How much does that give us?
Negative 4.
4 what? Negative 4y. Which one?
Negative 4.
So this gives us negative 4y. The 12 stays the same. Let's get rid of that negative 4. How do you do it?
Divide.
Good. In fact, we have a problem that's really similar to this one right there. What now?
What?
Yeah, when it's division, we keep that same sign. Okay, let's try one more together. I'll give you a couple to do on your own. What do you think you do first? What's your idea? Cool. Do I have any like terms?
Yeah.
Let's do that. Over here, we're good. We're x over -3. On the right-hand side, we're going to do a 12 minus 3. How much does that give us?
9.
And then lastly, we're going to do what? By what?
By -3.
As long as we do it on both sides. The 3's will be gone. I'll get x. On the right-hand side, we'll have -27. That's as good as we can get. Why don't you give 3 of these a try, and then we'll move on.
You tired of the noise, people?
No more motor. So combine like terms first, then you should have a problem like we've seen before. Okay, so the first one, we do have some like terms. Not on the left-hand side, that's just going to be x plus 6. There's nothing we can combine there. But on the right-hand side, we have 1 minus 3. Notice how you can use the combining like terms method to subtract these integers. I would circle the integers with their signs, just like that. We've done that before, right?
Yeah.
Use an addition rule there. The signs are different. You'd subtract, keep the sign of the bigger number, and you get how much? -2z. Would you raise your hand if you made it down that far? Good, that's fantastic, okay. Now we have a problem we've worked with before. We got one of those, or one of the ones I had up here on the board earlier. All we have to do is realize this is a one-step problem. Let's get everything away from x. In this case, we're going to be subtracting 6. And I'm hoping You got -8. Did you get -8?
Yeah.
Good deal. Could you check your answers?
Yes.
If you plug them into the original, it should work out. Let's do the next one. Of course, we do have some like terms. I know we know that 2m and -4m are like terms. If you're not circling those and you're messing up your signs, try circling them, because you have to circle with the sign. That's going to clue your mind into, oh, they have different signs. I need to subtract them, keep the sign a bigger number. Should we get 2m or -2m?
-2.
Good. On the left-hand side, 10 stays the same, but -2m is what we need to have on the right-hand side. Lastly, what are we going to do here?
Plus.
What now?
Divide by 2.
Good. By -2, that's great. We're going to get m equals
-5.
perfect. By the way, it doesn't matter the order in which you have this. You could have like over here, -4 equals b, or if you like it better, you could put b equals -4. It really doesn't matter what side that's on.
I didn't check your answer on the first one.
Well, you'd plug it in, but you'd have to do this math over again. So I'd recommend make sure you know you're doing this right and plug it into here. Okay. This one would probably be the easier one to plug it into. You do -8 plus 6 is -2. That is the same, because you'd have to redo that math anyway. Okay. Okay, last one. We're going to combine some like terms. -8 and 6, well, those have different signs. Subtraction on the bigger number. You need to be getting -2. On the right-hand side, we have y over 3 still, but we need to get rid of that 3. What are we going to do to get rid of that 3? We're going to do that to both sides. I'm going to keep the -2 in some parentheses to show that that's a negative. I'm not subtracting 2. It's 3 times -2. That's what we want to show. 3's are gone. I get y and... Perfect. By show of hands, how many people feel okay with what we just done? Good. Are you ready to start making this a little bit more advanced? Start building this up more and more and more. Okay, good. Pretty much for the rest of our time, it's going to be I do one, you do one. I do one, you do one. We're going to go back and forth like that. So you practice immediately what we're just learning, okay? All right, well, the first question would be, do I have any like terms?
Yes.
Before you get going on an equation, you absolutely must combine your like terms. So looking on the left-hand side of our equation, could you tell me what are my like terms on the left?
-4x.
So I need to combine those, 5x and -4x. Ladies and gentlemen, do I have any like terms with the 2? Do these count as like terms with this term?
No.
Different sides. Okay, if they're not on the same side, they cannot be like terms. So 5x minus 4x, how many x's are we going to get? Which one? Positive one or negative one?
X.
Sure, because we have different signs, you'll subtract, sign the bigger number, you get positive x. We don't need to write 1x because it's implied there's a 1 in front of it. What else do I need to write on the left-hand side?
+2.
Oh yeah, don't forget about that +2. We didn't do anything with that. Are you starting to see that really what we're doing is putting together a couple ideas? We're putting together combined like terms, which you've done before. We're putting together combining like terms or adding, subtracting integers, which you've done before with equations that we've just accomplished. So we're just tying all this stuff together. How about 7 and -19? How much does that give us?
Well,
Good.
That's it. No.
Well, you tell me, are we done?
No.
Do you have x by itself?
no.
Our goal is to get x by itself. Now we're really close. We've combined like terms, we've combined like terms. Man, this one looks a whole lot better than what we started with, right? This is just now a one-step problem. What's the one step?
Find
Okay.
-2.
Minus 2 for both sides.
So x and
Negative 14.
perfect. That's exactly right. Try one on your own. Be careful on your signs. That's where people get fouled up on this stuff. So I'm wanting you to combine some like terms. After you do that, it should be just a basic equation. If I look to combine some like terms, it's always our first step with equations. We look for like terms on the left, we look for like terms on the right, try to combine anything we can. On the right-hand side, I'm going to do the easy side first. I've got 19. 17 plus 2, no problem. Left-hand side, I do see some like terms. I'm seeing the negative 6y. You have to circle that number with the sign, and the plus 7y. How much is that going to give us, negative 6y and plus 7y?
1.
Good. And then?
Minus 1.
Sure, that minus 1, that has to be there as well. There's only one more step.
Plus
Positive.
Sure.
y equals 20.
Y equals 20. By show of hands, how many of you got y equals 20? Good for you, that's fantastic. Still got some equations. Do we have any like terms?
Yes.
For sure, let's combine them. On the right-hand side, why don't you tell me what I'm going to get when I combine my 15 and my minus 19? What am I going to get there, ladies and gentlemen?
Negative 4.
Perfect. I could do the circling, different signs, subtract sign of the bigger number, we get negative 4, you're absolutely right. On the left-hand side, I see the 7x, I see the minus 8x or negative 8x. What am I going to get out of that?
Negative x.
We got to be careful on this, whether you're going to get x or negative x. Definitely negative x, because we have different signs, we subtract sign of the bigger number. For sure, negative x. Now, you tell me, are we looking for negative x, or are we looking for x? This isn't good enough for us then. This is not good enough for us. How in the world do we get rid of the negative?
Divide by
Negative 1.
Negative to both sides.
Explain that.
Divided by negative 1.
Why?
Because there's a negative 1 in front of the x.
Yeah, I know a lot of you guys are so fond of doing this, writing 1x, right? Everyone loves writing 1x. Well, that means the same thing as x, right? Or vice versa, negative x means the same thing as negative 1x, doesn't it? Or negative 1 times x. You could just divide by negative 1. If we divide by negative 1, here the negatives are gone. That's essentially all you're doing. You're changing the signs. X equals, what's negative 4 divided by negative 1, folks?
Positive 4.
Positive 4 is it. Hey, do you remember how whenever you have just a negative in front of parentheses, essentially all it did was change every sign inside of that? That's basically what you're doing here. If you have negative x, listen carefully please if you want to learn something kind of quick thing. If you have negative x equals negative number or negative x equals a number, all you do to get positive x, just change the signs. That's all we're really doing. We're dividing by a negative. That's a negative 1. That's just changing the signs. Nod your head if you're with me. Yeah. You guys in the back there? Yeah. Okay, good. Well, let's bring up some old school stuff. Would you be able to do this problem?
Yeah.
I hope so. What's this problem entail?
Multiplication.
More specifically than multiplication is we're, say it again,
Distributing.
distributing. That's right, we're distributing. You can do that, right? Now watch. Look. I'm going to do one more thing to this. Instead of just distributing, now I'm going to say, okay, let's make this equal to 10x. Let's make it equal to 10x. What are we going to do? Well, the first thing you got to do is simplify both sides. Listen, in order to solve equations, you got to have something that looks like this. You got to have something that looks like that. Or something that looks like this one. You got to have that. So in order to solve our equations, the very first thing we're going to do, we're going to simplify both sides first. Simplify both sides first. What that means for you, if you're going to simplify both sides, that means you might have to distribute. And here we didn't have to distribute, we had no parentheses. But here, you guys just said, right? You said, didn't you? You're going to distribute that. So you might have to distribute, and you might have to combine some like terms. That's what simplifying means. It means distribute if you have parentheses, and it also means combine like terms if you have some like terms. LTs, like terms. Oh, let's give this a try. This is putting together a lot of good stuff, right? We just learned about distribution. So now we get to distribute, we get to combine some like terms, and we get to solve equations. You guys hit the jackpot today, didn't you? Whoa. I mean, my goodness. The only thing that would be better is if I have a whole box of pumpkins up here for you. I'm going to bring that up every day till Halloween. You know that, right? You know pumpkins are going up in cost? Did I tell you about that? Anybody go home and try the tortilla pizza that I was talking about?
I'm out of tortillas.
Out of tortillas. I'm not even out of tortillas. Like Costco, 4 tortillas for like $3. It's the best.
You have tortillas?
Okay, so refresh my memory. You don't need ingredients. You can pasta sauce and pepperoni. Yeah, I guess so. It is gross. It's really not that good.
Is it really not good?
No.
Why are you trying to make us eat?
Just say it. Just say it.
You look so, like, you convinced me that it was kind of good when you turned around, like, anybody try it?
Yeah, no, it's not good.
It sounds like it's like a pizza burrito.
Pizzerito. Oh, Pizzerito. You should have bet that, Jeff. Be a millionaire. But this is on video, so I have rights to that.
Oh, that is true.
So Pizzerito, if you sell that, I get like 20. Let's say 20%. Deal?
You're gonna
Just say 20%.
Sure, whatever.
Yes, or whatever. Love it. Okay, let's go ahead and see if we refresh my memory on how you distribute this thing. What do you do to distribute,
3
please?
times 3.
Notice how we're ignoring the side of the equation right now. We're just focused on the left-hand side and doing what we've done for a long time now, which is just distribute. 3 times 3x, everybody gives you what?
9x.
Minus what? Good, because we do 3 times -7, that gives us -21. We're going to write -21. We practiced that a lot yesterday. 10x doesn't change, and now we have something we can work with. But this looks a little different to you, I hope.
Yeah.
I want you to take a look at this, please. I showed this to you one time before. Do you have any like terms?
No.
Good. Like terms are on the same side of the equation. So here we don't have like terms. Listen carefully. This is why you do what I told you to do before. You have to somehow get your x's to one side. We have to remove one of these x's completely. The only way you can do it is by addition or subtraction. What we're going to look for in this case is the smaller of the two variables. What's the smaller variable? Okay. So we're going to eliminate the smaller variable by either addition or subtraction. What do I need to do here for our 9x? Add or subtract?
Subtract.
Subtract. Now watch what happens in terms of like terms. Is kind of interesting. If I subtract 9x, don't I also have to do it over here?
Yeah.
Watch, as soon as I do that, what I do to one side, I do to the other. Now do you see these are on the same side of the equation? Now they're like terms. Now we can combine them. That's why we do what we do. On the left-hand side, the 9x's are gone. What am I going to have on the left-hand side? Left-hand side. On the right-hand side, 10x minus 9x gives you...
X.
Do you need to do any more work?
No.
You're done. X is negative 21. That's kind of nice. That's kind of nice. Why don't you try one of these on your own, okay? There you go. So if you want a note for this one, by the way, you're going to eliminate the smaller variable first. Or eliminate smaller variable by addition, subtraction. Some of you guys done on this already? Quick. Wow. That's good. Must be really good at your distribution or something. So when we start our problem, we're looking for anything we need to simplify. On the left-hand side, we're good. We just have 13x. You can't do much with that right now. On the right-hand side, though, we've got the 4 being distributed across those parentheses. That's what we learned how to do throughout the entire last section. We're just distributing a positive 4. So we're taking positive 4 times positive 3x and getting 12x. We're taking positive 4 times what we consider that to be negative 1 and get negative 4. Perfect. So we write minus 4. Now tell me the next step that I'm going to do.
Subtract.
Good. That's our smaller variable. So if I get rid of my smaller variable, which is the 12x, it's got to be by addition subtraction. Now, for some people this gets a little confusing because I know that before when we had like a number out in front, we divide. But notice how we don't even have our x's together yet. The appropriate step is not to divide by 12 here. All that would do is eliminate the 12, not the x. If you divide by 12x, you have x's everywhere. Your problem's going to explode. Your paper's going to go, what are you doing to me? Please, don't ruin me. You have to erase all this. Come on, man. Yeah, you don't want to do that. If we get rid of the smaller variable by addition subtraction, it removes the entire thing. It moves it over to the other side. That's what we want to do. So we subtract our 12x. That's our smaller variable from both sides. Left-hand side, 13x minus 12x, we get x. Right-hand side, we get 4. Yeah, and you're done. Now, the thing about this is kind of, well, these are unique examples, aren't they? Because this has been like only one number apart here, and only one number apart here. And so we've got x every time. Not coincidentally, I set these problems up so we would get that. But does that happen all the time, do you think?
No.
So we need to focus on a different type of problem. Because right now we've just had one-steppers, basically. One-step problems after we combine like terms. We need to focus on what happens if I don't have a one-step problem. Like that. See, before, if I just gave you this, watch on the board. Watch on the board. If I just gave you this, you could do that, right?
Yeah.
You'd add 5. If I just gave you this, you could do that. You just divide by 3. But now when I give you this, you have a combination of things that's happening to this y. We got to know what to do when. So when we have 3y minus 5 equals 16, firstly, is this an equation?
Yes.
Definitely. What's your variable?
Y.
I've got 2 things happening to y. Y is being multiplied by 3. Y is also being subtracted by 5. We've got to get rid of both of those things. The question is, which one do you do first? Now, before you answer and shout something out, let me explain to you how to think about this process, okay? The process is we're trying to undo the things around our y variable. Listen carefully to what I'm saying here. Try to undo things, right? If you're undoing, it's kind of like you're going backwards. When you get up in the morning, well, unless you just sleep in your clothes that you wear during the day, which whatever, it's up to you. I'm not judging. But you probably put clothes on, right? You probably put, hopefully, your socks on before your shoes. True? That looked really silly the other way around. You probably get blisters. No one wants blisters. So you put your socks on, and then you put your shoes on. To get undressed, do you take your socks off first or your shoes off first? So we're going in the reverse order of what we normally do. In other words, in this example, we're going the opposite of order of operations. Does that make sense? We're undoing things. So if you get dressed in the morning, you go socks then shoes. That's building an equation. If you get undressed, you go shoes then socks. That's undoing an equation. We are undoing equations right now. So when you look at this problem, we go, okay, 3 is being multiplied by y and subtracting by 5. We're going to go reverse order of operations on our equations, which means that the first thing we get rid of is anything that is added or subtracted.
We're doing sad map.
Sad map. Sad map. That's right. You go in reverse. You're undoing your equation. If you try to divide by 3, you're going to have a problem. What we need to get rid of first is the constant. Any constant term gets eliminated first by addition subtraction. So write that down, please. The first thing you do, you get rid of the constant term first. Get rid of the constant first. The constant number, ladies and gentlemen, is just a number by itself. And I'm not talking about the coefficient, I'm talking about the number being added or subtracted if there is one. So get rid of the constant first. This will always be by addition subtraction. Get rid of the constant first, always by addition subtraction. Hey, let's give that a try, okay? Let's give that a try. If we get rid of the constant term, can you please tell me how to get rid of the constant term?
And
Okay. I will get 3y on the left. I will get how much on the right? Hey, is that a problem you've seen before? Now that's something we can deal with. You get rid of the constant term first by addition subtraction. The next step is to get rid of the coefficient. The coefficient is a number in front of y. Remember that word coefficient?
Yeah.
You get rid of the coefficient, that's by division or multiplication. So the last step, the first time you divide is on the last step. The last thing you do is divide. That's it. You never divide earlier in the problem. That's not going to work. So get rid of coefficient. Coefficient is the number in front of your variable. This is going to be by multiplication or division. For us, it's almost exclusively by division. Let's try it. So when we look at our problem, we know we got to get rid of the 3. How do we get rid of the 3?
negative 3y.
Divided by 3.
Yeah, this is 3 times y, right? So we're going to get rid of the 3 times. That means we're going to divide.
7.
Those 3's create that 1, right? 3 divided by 3 gives us that 1. That's why this thing works. So when we divide by 3, we get y on the left. We get how much on the right?
7.
And we're done. That's something we can live with. We're going to start here next time. How many people understood what we talked about so far? Good. This might take a little bit of practice. We are going to build up these more and more. I have to be solid on this before we go any further. So, well, welcome. Yesterday was Sunday, Friday, last time you were here. We were talking about how to solve equations, and really what we've been realizing is that when we distribute and we combine like terms, that was leading up to our equations. If we combine that idea with equations, get rid of our smallest variable, we can solve a lot of different problems that look hard to begin with, but really aren't all that bad. Now, I believe last time we were talking about one problem that looked a whole lot like this. Where we have not just a one-step problem, but two numbers we need to get rid of. One of them is a constant number, and one of them is called the coefficient, which is just a number in front of the variable. What I need you to know is which one to undo first. If you remember about Friday, what we talked about was we're trying to undo operations which are around our variable. So in our case, we're trying to get rid of or eliminate both the 5 and the 2. The question is which one we do first. Do we try to eliminate the 5 first, or do we try to eliminate the 2 first? And I think I gave you some answers on that on Friday. Which one?
The 2.
Is the 2 the constant or the coefficient? Good, so we eliminated our constant first. I gave you notes on that. I said, first thing you do, you get rid of your constant. Whatever's being added or subtracted at the end, we eliminate that first. We are going in reverse order of order operations. So the first thing we get rid of is addition or subtraction, whatever we have there. Are you with me, folks?
Yeah.
So let's do that. We're going to, how do we get rid of that 2?
Subtract 2.
And if I do it on one side, that means it's got to be level. It's got to be even. On the left-hand side, what happens? Good, yeah, I do, because I haven't done anything with that. And everybody on the right-hand side, I get
15.
That wasn't everybody. Come on, folks. Wake it up to the... There we go. 5y equals 15. Hey, now that's a problem we've seen before, right? As soon as we get rid of the constant, there's really only one more step that we have to do. And that is typically to multiply or divide. Almost exclusive for us, divide. So when we divide this problem, we'll divide both sides by 5 in our case. And we get y equals to... By the way, can you still check your answer here?
Yes.
If you plug it in, check it out. What's 5 times 3?
15.
Plus 2? Hey, it works. It works. We can always check our answers. So, what we're doing in this, after we simplify, after we combine like terms, after we get rid of the smallest variable, if there are 2, we eliminate the constant by addition and subtraction, then we eliminate the coefficient by division. That's really all there is to it. It's a set number of steps. It's a set step that we do every single time to solve these equations. If you get the hang of it, you're going to get them right. Almost all the time. Maybe some math errors every once in a while, but usually that's what happens, is that we're able to do this and be just fine with it. And we're going to build on this in the next section. Let's try a few examples right now. I'll do 2 with you. I'll give you 2 to do on your own. We'll talk about how to translate some sentences into equations and solve those, and then we'll be done with our section. Okay, this looks a little better. Okay, we're going to do this together, but you got to tell me what to do, because I want to make sure that you know it. Of course, I know how to do this stuff, right? I want to make sure you know how to do this stuff. What's the first thing you do in this problem?
Combine like terms.
Good. Do I have any like terms to combine?
4 and n.
I can do that. How much does that give us?
5.
Remember that we have an equation here, so we're going to keep this stuff on the left, this stuff on the right. 5m, what about the minus 7? Okay, very good. We got those. We bring down that minus 7. We can't do anything with that. On the right-hand side, I do have some like terms because we know numbers are always like terms. How much are we going to get on the right-hand side? By the way, just to make sure you remember this, are -7 and 8 like terms?
No, because they're on the same side.
Yeah, that's right. That's exactly right. Did you hear him in the back?
No.
Why aren't these like terms?
They're not on the same side.
Perfect. Hey, as soon as we combine like terms, you see what happens? We get a problem just like we solved. That's what's going to happen, is you're going to get a problem just like the one right up there. Every time you combine like terms, you'll either have this situation, or you might have another variable over here, but we will deal with that. We've already actually dealt with it, but we'll deal with that even more in the next section. So as soon as you combine like terms, you're going to have something like that. Now, what do we need to get rid of here? There's 2 things. What are the 2 things?
7.
We need to get rid of the 7, and we need to get rid of what?
5.
Which one comes first, the 7 or the 5?
7.
Let's get rid of the 7. How am I going to get rid of that 7?
By adding
So in our case, we get 5m equals 15. By the way, it doesn't always end up that way. It's not always going to be 3, I promise. Just in this coincidence. We divide by 5. That's always our last step to do. And we're going to get m equals 3.
Why is it that we don't leave like that?
Leave it like what?
Because there's
You're trying to figure out what m is.
Trying to solve for m. Got to get m all the way down where it just says m equals that number. Let's do one more together. Oh my goodness. Hey, what would you do first? If this was your problem, what would you do? See that? If we have any like terms, we can do that. But however, I want you to look at the problem. On this right-hand side, before we start looking for like terms, you're going to have to do something. What's that called? Parentheses, and more specifically, you said in the back, what's it called? You're going to have to distribute. That's exactly right. Let's distribute that. Folks, we need to be perfect at distribution. Why don't you tell me what number are we going to distribute in this problem? Good. Not just 5, right? Not just 5. We've got to have that negative in front of it. So when we're looking at this, sure, we are distributing the 5, but we're also distributing that negative sign with it. That's why I'm having you circle the number with the sign. Does it go to the first term, the second term, or both terms, ladies and gentlemen?
Both.
Does it just go to just this one?
No.
Just this one? Or both? Can you tell me what I'm going to get for the first term, folks? Perfect. Hey, someone else tell me what I'm going to get for the second term.
minus 20 or negative.
Are we adding or multiplying? So we got to multiply term by term. What's negative 5 times positive 4? Remember, we're taking this term with its sign
20.
and this term with its sign, minus 20. Do you guys all see the minus 20?
Yes.
Put a minus 20 up there. What else do I have? Good, that negative 5 doesn't distribute to the minus 39, just out there at the very end. Would you raise your hand if you're okay with this so far? Good. Now's the point where we can combine those like terms. If we have any, we put them together. I see on the left-hand side, I've got a 2 and a minus 6. How much does our 2 and our negative 6 give us? Equals, we do have that negative 5x, but when we're combining like terms, we consider these terms with their signs, because we can separate into plus negatives. Remember doing that? We can do that. We're just kind of cheating the problem a little bit. How much is it?
59 or negative 50.
Negative 59. So if it's negative 59, we'll put our minus 59.
And you gotta add 59.
Yeah, let's look at that. If our x is on the right-hand side, which it really hasn't been all that often for us, are we trying to get rid of the negative 4? Is that something we want to do? No, we really want to get rid of these two numbers around the x. That's what we're focusing on. We know that this is an equation, and we know what we want. The only thing over here to be x. That's what we want. Are we getting rid of the negative 5 first or the negative 59 first?
Negative 59.
Negative 59. Because that is our, what's that called again?
That's a constant.
And what's this one called again? Do you guys know that word? Coefficient. Can y'all say coefficient for me?
Coefficient.
Yeah, that's the one that's in front of your variable. The one all by itself out here with added or subtracted, that's called your constant. The one next to your variable that's being multiplied by your variable is your coefficient. How are we going to get rid of the minus 59? Okay, left-hand side. We got different signs. We're going to subtract, sign the bigger number. What do you get on the left? You guys with me today?
Positive 55.
Are you with me? Are you awake? I need a little bit more out of you. I need more than this.
Positive 55.
I hear you, Jen. I hear you, Jen. I got you. On the right-hand side, what do we have?
0.
What's our last step when we're solving equations? What that's going to be?
Divide.
Yep, we are going to divide because we have this being multiplied. If we divide by -5, which is what we're supposed to do, remember we're taking the number with the sign, the exact same thing. That's what you divide by. That's the only way you're going to actually get rid of that negative. Otherwise, you just get rid of the 5. On the left, we get 55 divided by -5 is,
Oh,
on the left-hand side, 55 divided by -5 is, on the right, you can still check your work. It's a little bit more involved because you have to do a whole lot of math with it, but it still will work out for you. Hey, are you ready to try a couple on your own? Let's do that. I'll be walking around. If you need help on this, let me know. I'll help you. Lots of good work so far. Good distribution on the second problem. I like it. Good watching out for your signs on the first problem. That was good too. Okay. So when I'm looking at these problems, the first thing I'm looking for is to try to simplify both sides. We talked about that on Friday. That means we're going to distribute, and if we have to, combine like terms. If we need to, then we're going to solve these equations. So on our first problem, we have a 5x and a negative 9x. I'm seeing that right away as my like terms. So right here, I'm going to combine those, and I'm going to get 5x and minus 9x. How much does that give you? Good. Of course, I have a plus 3. That's going to equal on the right-hand side. I'll combine those terms as well. 19 and minus 4, that gives you... And now pretty much home free. we have just two steps to do. One of them is going to be addition subtraction to get rid of our constant. The other one's going to be dividing to get rid of our coefficient. So we'll draw our line, making sure we know what we do to the left side, we also do the right. We'll subtract 3 on both sides to get rid of that plus 3. That will give you the minus or negative 4x equals 12. And our last step is to get rid of the coefficient. This is the place where you divide. You're not going to divide before this, only right here. So when we divide by negative 4, divided by negative 4, we're using the division rules. Different signs means you're going to get the negative out of that, negative 3. By show of hands, how many got negative 3? Good for you. If you didn't, where'd your mistake come from? Did it come from combined like terms? If you do this, check it out. If you do this and you get a positive 4x, is your problem going to turn out right?
No.
Not quite so much. You're going to be off by a sign. If you're mistaking on doing these, the subtracting 3 and getting your signs wrong, pretty much a lot of people just mess up signs on these problems. Positives and negatives. That's why we covered it so in depth in chapter 2. It's because a lot of times people mess up the positive and the negative, or they'll mess up addition rule. That's really where the mistakes happen. Most people understand the concept that you're supposed to get rid of the constant first, then you're supposed to get rid of the coefficient, but actually doing that, that's where the mistakes happen. So if you're making mistakes on this stuff, go back and review that. That will really help you. Okay, last one on the board for us. Of course we're going to distribute. We've got to combine some like terms, and we have to do, in order to do that, we've got to get rid of our parentheses there. So we're going to look at this problem and distribute our negative 4. It'll go to both of our terms, and you should have gotten negative 4x plus 8 or minus 8?
Minus.
Good, I'm glad you saw that. Negative, positive means a minus, or a negative for us. We still have that minus 60. On the right-hand side, we got our 2 minus 10. If you want to do the 2 minus 10 and get negative 8 at this point, that's fine. It doesn't matter. I'm going to hold off to combine like terms in the next step, just because I want to make sure I do everything at one time. So we've distributed. Now's the point where, before we go any further, we're going to combine some like terms. I have some like terms, as a matter of fact, not the 4x so much, but I do have a minus 8 and a minus 60. I'm using the addition rule to combine like terms. That means we have the same signs. You will add them together, keep the common sign, and get minus 68. That's right. On the right-hand side, I do have like terms. I got 2 and minus 10, or negative 10. We're going to consider it because we write the plus negative. We've got different signs. That means I'll subtract. I'll keep the sign of the bigger number, and I'm going to get
Negative 8.
perfect. Okay, now comes one of the other key points we're just learning right now. What number are we supposed to get rid of? Are we supposed to get rid of the negative 8, the minus 68, or the negative 4? Yeah, that's the one. We want to get rid of the constant term first, away from the x. If you try to do this number, it's going to make this side worse. You don't want to do that. You want to make this side better. Get stuff away from the x. So we'll add 68 to both sides. We'll have negative 4x equals how much?
60.
Positive.
And our last step when we're doing this is going to be to divide. We're going to get rid of that coefficient. If we divide by negative 4 on both sides, notice how we're dividing by negative 4, not just 4. We got to have that negative there. X gives you, what's 60 divided by negative 4? Perfect. We're good to go. That's as much as examples I have for you on this topic. How many people feel okay with solving that? Good, all right, good. We're going to continue building on this in the next section, but for right now, I need to make sure that you can translate sentences into equations. So we're going to do a little translation here. By the way, I need you to refresh your memory on the words that mean like add, subtract, multiply, divide, all that stuff. On page 173, that's a good list. That will tell you all the words that mean equals and addition, subtraction, multiplication, division. Read through that on page 173 for me before you try your homework. For right now, we're going to translate expressions. We'll get into equations in a bit. This is just a first step, trying to do one side of an equation. So we're going to look at some expressions and see if we can write them as math symbols. That's pretty much it. Taking a sentence, writing it in terms of math.
This section of these is word problem.
So the sum of -3 and a number. Sum of -3 and a number. The first thing we're doing, I think I taught this to you before in this class, we're going to identify any words up here that mean math, we'll underline them, and we'll put the actual symbols for them. So we're through our question here. The sum of -3 and a number. What's one word up here that means math?
Sum.
What's sum mean?
Addition.
Good. So we're gonna be adding there. So sum means addition. We put a plus down. That lets us our mind know, okay, this is what we're gonna be doing in this problem. We're gonna be adding something. What else means some math up here? What now? Okay.
Number?
And a number. The sum of something and something else. A number means math. What's a number mean?
Variable.
A letter.
Good. Letter I'm gonna pick is T. So the sum of -3 and a number, there's only a couple operations in math that are written back, a couple ways to say addition, subtraction, multiplication, division, they're written backwards. Sum is written the same way that you see it on the paper. So when you see the sum of -3 and a number, what this means is we'll put -3, we'll put our sum, we'll put our number. That's how you translate from a sentence to, or an expression to a math expression, a sentence expression to a math expression. We underline our words that mean addition or subtraction, whatever operation we're dealing with, our variable. Then we try to translate from this sentence to this. If we underline it, it helps us out a lot. Are you guys okay on going from this sentence to this expression?
Yeah.
Okay. Let's try a few more. I'll start building them up in just a bit. But for right now, let's keep it kind of simple. Let's try that one. -5 decreased by a number. You tell me what up here means some math.
Decrease.
What's decreased mean?
Subtract.
Good. Decreased by means you're going to have this, then you're going to subtract whatever comes next. So -5 decreased by something, by a number, means you're going to have -5 minus, what's our number?
It's a variable.
What is that going to be?
And
Who did I pick? Who said n?
me.
Did you? Congratulations, you win. So -5 decreased by a number n. -5 minus n. It's written that way. -5 comes first. It says decreased by. Anytime it says decreased by, that thing's coming after that. This is a good one for you to pay attention to up here, all right? A number subtracted from 20. Well, the first thing I know is that a number means a variable. Oh, let's try this one. You ready? Think of a variable. See if I pick it. Are you thinking of? No, don't think of it. I'm not going to pick R now. Oh, you lose. You're losing. You just have to think of it. Hold in your head. You ready? How about Y? Anybody think Y? No winners. There's 26 to choose from. I guess that'd be hard enough.
Somebody will look at it.
Someone will. Someone will. A number subtracted from 20. Subtracted from. We all know that subtraction means, well, subtraction. But here's the key thing. When it says subtracted from, this is a big deal for you. It says a number subtracted from. What it means is that from means it's coming after that 20. or the less than. The less than means it's coming after whatever number's before it. So when you say a number subtracted from 20, a lot of people on their homework, I guarantee look at the board right now for me. A lot of people are going to give me this. A lot of people are going to be very wrong. That's the wrong answer here. Don't write this one down, or write it down and put a cross out through it if you want to. This is not y minus 20. This is not y subtract 20. This is y subtracted from 20. That from 20 means, sure, you had 20, and then you subtracted y from it. It's 20 minus y. Is it going to make a difference, do you think, on y minus 20 and 20 minus y?
Oh, yeah.
One's going to be positive, one's going to be negative. That's the difference. So if you put that on there, you're going to have an issue. Well, your numbers are going to be different. Often it'll be off by a sign. For instance, if I do 5 minus 20, I get negative 15. If I do 20 minus 5, I get positive 15. It will be not the same. Not the same at all. How many understood that concept there? Good, all right. All right, let's try this one. The quotient of a number and 4. Quotient of a number and 4. Let's underline some words that mean math right off the bat. What is a word that means math for me?
Quotient.
What's quotient mean? It's got to be either add, subtract, multiply, or divide, right? Which one? Say it again.
Divide.
Yeah, that means divide. Whenever you see quotient, we mean divide. If you're a little fuzzy on these, please go back, refresh your memory on page 173. These words are up there. Another thing that means math, we've dealt with this a few times now, a number. Oh, pick a number.
T.
Oh, I like J. That'd be good.
T.
Yeah, T.
L.
I got J.
L.
I said J. I'll pick J. J for Jimmy Johnson. You guys watch NASCAR? Shame on you.
You didn't do too good.
I don't know. Didn't watch the race. Yeah. Thanks for ruining it for me, Kevin. Appreciate it. So the quotient of a number and 4, this is in order. It's just like a sum is in order. So if we have a quotient of a number and 4, we're going to have J over 4. That's the way we're writing division. It's going to be a fraction. Now, do you feel all right with these examples I've given you? We're going to step it up a little bit. These are just pretty much two things either connected by addition, subtraction, multiplication, division. We're going to step it up, ramp this up, and see if we can make something a little bit more complex that we've been dealing with already. For instance, the product of 5 and a number decreased by 21. We're going to go through the same process that we just finished. We're going to underline some key words here. What's the first key word I might want to underline?
Product.
What's product mean?
Multiply.
The product of 5 and, I know a number could be anything. Let's pick,
H.
oh, okay, H could work. I don't really like picking S's because they look like 5s for me. That's the only reason. So H would work for me. What else needs to be underlined?
Decreased.
Decreased by, okay. What's decreased by mean?
Subtracted from.
Decreased by does not mean subtracted from. Decreased by means minus the rest. Subtracted from would be written at the end of our sentence. This would be a number subtracted from would be like y minus, it would be 20 minus y, subtracted from 20. Decreased by, this states what it's being decreased by. It's being decreased by 21. So whatever we're going to have, we're going to subtract 21 from it. Do you see the difference between that problem and that problem? Subtracted from? Yeah, that comes at the end. You're taking that away from something. Here, decreased by 21 says whatever you're going to have, you are going to subtract 21 from it. So we need to identify the first part and then subtract 21 from that part. So can you write out, ignore this for a second, can you write out the product of 5 and a number, h? Can you write out the product of 5 and a number, h? How much is that?
H.
Now what this said is whatever you got here, it's going to be decreased by 21. How do we show decreased by 21?
Subtract, minus 21.
That's the way we write that or represent that expression. Let's try a couple more. It looks like we need a little bit more help on this thing, and then we'll be good. Twice the sum of a number and 7. I'm going to help you out with this one because you might not know what twice means. Whenever you see twice mean what number is associated with twice? 2. So if I have twice 5, how much is twice 5?
Squared.
Not squared. 2 times.
Plus 2.
Times 2. So if I have twice 5, it means I have 5 twice, or 10. If I have twice 20, it means 2 times 20. So twice means 2 times. Then we see twice. Twice means 2 times. That's what twice is for us. So twice we underline that. Sum, I already know that means plus. A number, I already know that could be anything. Let's pick B. So twice the sum of a number and 7. Here's the deal. Whenever it says like the product of, or twice the, or sum of, and it doesn't give you a number afterwards, it says twice the, and then says, wait, not twice 7 or twice, not twice a number, it says twice the sum of something. What this kind of suggests to you is this part is going to be in parentheses. I hope you would listen to that. You made a note of that. You can watch some video again. Whenever it says like twice the, or product of, or sum of, and then it gives you something else besides a number or a variable, what that signifies is that you are going to have a parentheses. Here's what this says. Twice the sum of a number and 7. What you need to do is find the sum of a number and 7 and then take twice that or multiply it by 2. So what's the sum of a number and 7 or b and 7? How would you write that?
B plus 7.
Say that louder for me, please.
B plus 7.
Yeah, good. See, I don't want just twice. I don't want this. Look at the board. I want you to see the difference. If I did that, is that right?
2b.
This says twice b
2
plus 7.
b.
This doesn't say twice the sum of b and 7. Twice the sum would be that. That's where those parentheses are coming from. So whenever you read that, it says twice or the product of or something, the product of like the sum, product of the sum, that suggests or twice the sum or quotient of the sum. It suggests there's going to be parentheses somewhere. If it doesn't give you directly what you want, it says you're probably going to have some parentheses. Watch out for that. And here, of course, we have that. Twice the sum of what? Well, these two things. That's what you're asking.
Is that what the actual?
That's it. Now, if you wanted to distribute, could you distribute?
No.
You could do. Yeah, you could give me that. Well, not that. You could do that. 2b plus 14 if you'd like. But to get this thing just from here to our expression, this is fine. This is where you can stop for me, okay? Let's try one more for our section here. Actually, you know what? Why don't you try? I'll give you a couple minutes, see if you can work this thing out. the quotient of 11 and twice a number. Quotient of 11 and twice a number. Give that a try. So we're underlining the key words, find out what those mean mathematically. Then we write out our expression. And if you'd like to, you can distribute. I don't think you will on this one, though.
No.
Brian. For some reason, I thought you were Kevin. I don't know. Call him Kevin all the time. You just were like, oh yeah. Oh, you're Kevin.
Easy.
Like a Sunday.
I've been called worse.
Is Kevin here? Well, I've never been called worse than Kevin, that's for sure. Sorry about that, Brian.
No problem, Joe.
All right.
No, I won't go that far.
Okay, so let's go ahead and do this problem together. We have the quotient of 11 and twice the number. So when we have the quotient, of course we mean divide. Quotient of 11, that's not really much, but twice, we know that twice means 2 times, and a number means some variable that you pick. I'll pick z. You both pick z?
I did earlier.
Did you? Oh, we were almost the same wavelength, but we're not. The quotient of 11 and, if it doesn't say 11 and something else directly, this says 11 and twice a number. What this signifies is that this is going to be together somewhere. That 2z is going to be together somewhere. So the quotient of 11 says the quotient of whatever comes first is going to be on the top of your fraction. Quotient of 11 and the rest of it's going to be on the bottom of your fraction. So if it says quotient of 11 and twice a number, that twice a number is going to be right down here on the denominator. You should have 2z. How many people have exactly that?
I did it for 11 on the bottom.
Okay, flip that around. The quotient, whatever comes first, is on the top of your fraction. So when it says quotient of 11, that means bam, 11's got to be there. The twice a number, that's going on the denominator.
I got the same thing, but I prefer these on the
Like this?
no, just on the feet.
Like,
Or on the Z.
huh?
Yeah, like that.
Yeah, that's fine. It means the same thing. It doesn't really matter. As long as you have these in the same position and they mean the same thing, that's what I care about right now. How many people feel okay on these expressions? I know these get a little tough sometimes. You really have to stop and think about them. Don't just skip them on your homework. They are going to be on your test. Hope you caught that. Make a little note. These will be on your test. I will check you for them. So make sure you know how to do those, okay?